Hello everyone, thank you for dialing in to the do's and don'ts of Define.xml. My name is David Roulstone. I work for Pinnacle 21. I'm currently involved with two different projects at the FDA. One, the Standards Testing project, looking at new CDISC standards as they are released, and the other one, performing data fitness assessments for CBER submissions. I have a bit over 10 years experience, mostly focused on data conversions and data standards. We are accepting questions throughout this webinar. All the questions we will answer questions at the end and try to get to as many as we can. For any questions that we don't get to, we'll answer those after the presentations. We are recording, and all the attendees will get a link to a recording of the presentation, the slides, and also answers to all the questions. So looking at the agenda today, it's really focused on content. We're not going to get into anything technical. We're not going to look at any of the XML code. Also not going to really talk about the different standards with Define, whether that be 1.0, 2.0, or the soon to be released 2.1. Really, this presentation's just designed to quickly see if little tips and tricks that we've picked up throughout the years to see how well put together and well formed the XML document is. Often that there's just one person creating the Define file and a second person QCing it. And this is just, if you get quite often we've received defines that have been fully QC'd, and then when you really start digging into the details, you discover that someone rushed through it a bit too quickly. So to start off, we have this is a quote out of the FDA's Technical Conformance Guide. So they actually state that they consider the Define.xml arguably the most important part of the electronic dataset submission. And one important thing to remember with your Define.xml is all the various users who will be looking to your Define file to get familiar with the study. So a lot of the users, you can assume that they've probably never even seen the study before. A lot of the time, someone reading your Define file hasn't read the protocol in a great amount of detail. They might know some of the basics around the study, but really haven't looked at it in depth. The end users of your Define file certainly won't have any information about the raw database. So the FDA, the PMDA, they do not have any info about your raw database, any access to it. Another thing is that some of the people looking at your Define might not have too much of an understanding about CDISC standards. Some of the medical reviewers really aren't going to be all that familiar with all the CDISC nuances. But the main thing is that when they're looking at your Define, they're really looking to get familiar with the study, the data, and the documents. And they're really looking at your Define file in order to explain all of this information before them. As far as the content in your Define file is concerned, the content, it's really there to explain the data. Any derivations that you have in your Define should be quick and to the point and precise as possible. The Define should not be too complicated. That's especially true when talking about derivations. There really shouldn't be any, people shouldn't need programming knowledge in order to be able to understand your Define file. And lastly, we really don't want to overload the Define with too much unnecessary information. So we're just going to go through just some do's and don'ts, and then we'll move on to some real world examples. So one fairly easy mistake that we see made, or often I think it's just people cutting corners, is when they have something that's truly derived, but maybe they're having problems getting that exact derivation. It's possible that the person creating the define file didn't work with the data. For whatever reason, one simple way out to get out of providing your derivation would be to simply list out your variable or value level metadata as being assigned. So one quick check for this would be to pick something that usually has a long derivation, such as exdose or epoch. Go through that or look at the define file and see the derivation listed there. If they've got very complex calculations for exdose, but it just says assigned in the define file, or same with the epoch derivations. If it says assigned for epoch in adverse events, it's probably due to laziness and the fact that they didn't want to list out the derivation. Another common mistake that we see is just a lack of information. So there is a bit of a fine line between providing too much information and then not enough information. Generally, when it's not enough information, that's someone who is possibly not all that close with the CDISC standards and is, again, primarily focused on creating the define file as their job. What we see there is the person creating the define sometimes gets a bit too comfortable with their own internal standards or confuses them with the CDISC standards. And what we often see is that the sponsor-specific standards are not properly documented. And then lastly, before we go to an example, raw data references is another issue that we see often. As previously stated, the FDA and the PMDA won't have access to the raw database or know anything about it. So derivations that are in your mapping spec, most of the time you cannot copy them directly out of your mapping spec and put them into the define file. You have to go through and correct some of the text, take out any references to raw data, and update it so that the language is in SAND, SDTM, or ATOM language. So looking at this example here, this was a define file that came through for us just to check prior to a submission. So the first thing we notice is we do have some comments listed out here for the Medra variables. They're not all that useful though. They're really just the raw database variables. They happen to be called, given the same names as the SDTM variables. I guess this is an example of sometimes it's not really worth putting absolutely everything you can into the define file because these comments circled here don't really offer anything new. And if anything, can lead to some human error when putting in those values. The next thing we see is they do have the CRF, they do have the origin for AE SPID listed as CRF, but they don't have a page number. So that looks a little bit fishy to begin with. And then the comment is AE.record position. So this is one of the raw database variables. This does touch on to people leaving out their own internal standards. So we did, after questioning the client and asking about, this origin and the AE.record position, it actually turns out that they use SPID between their raw data, their SDTM, and their ATOM data to provide traceability. Unfortunately, that detail wasn't put into the define file, and that info was lost. The next thing we can see is AE term. There's a case statement in here, which almost looks like a derivation, but then when we look a bit closer, we can see some raw database references. And really, that comment there, it's operational. It's for the database only. And also, it doesn't offer any value. AE term is, for this study, it was just free text collected on the CRF like it is most of the time. So having that extra comment in there was unnecessary. And then lastly, the Medra dictionary has not been assigned to these Medra coding variables. So this is actually an issue with If this was to go to the FDA in its current state, the data fit validation would actually note that there's no Medra dictionary assigned to these coding variables and would actually validate against the latest version of Medra. If this was to go to the PMDA, on the other hand, then it would be a rejection criteria. So this is the before, and then on the next page here we have the after. Not too much has changed. Remove the unnecessary comments for the Medra dictionaries. Correctly assigned the Medra dictionary to the variables under the controlled terms column. Set a SPID to an origin of EDT. Remove the unnecessary AE term comment. Possibly most importantly, we've also put in a very quick 2 sentences just to explain how SPID is being used in this study. Another issue that we see quite often is incorrect information. Generally, it seems that the main cause of this is when there's protocol amendments. You might have pages that are removed or added to the CRF. That'll definitely affect your page numbers and the origins in the define. People are often too focused on QCing the data and making sure that that's correct, and the define's often left for a later date to QC. So a quick tip that I like to do is just to open up the CRF to the last page, or look at one of the last annotations on the CRF, find that SDT or find that variable, and then look at it in the define file just to make sure that the page numbers, the page number origin given in the define file matches with the CRF page. And then another good one, again, picking up as far as incorrect information goes, if you pick a really hard derivation, again, EX-dose or EPIC is a good one. If you have a case statement for EX-dose and it's looking for 5 different treatments within your exposure domain, yet your exposure domain has 6 treatments, it's probably a good indication that the define file might need to be updated. And then just before we look at another example, just to mention about formatting issues. So the Define.xml does not support any formatting really, so no bullet points, numbered lists, or any new line characters or carriage returns. So here is another real life example that came through here. Quite a complex derivation for EX-dose. This was a package all set to go to submission. We're just sort of looking over everything, the data, all the reviewer's guides, define files, annotations. We did take a look at the EX-dose here. It's quite hard to understand and probably spent a good 10-15 minutes copying out that text just into Notepad just so we could rearrange it and just try and make a little bit more sense of it. In the end, we just were completely unable to make out what was happening here. So we had to go back to the client and ask them to update it. So on the next slide here, it looks extremely similar to before. All we had them do was just add an extra sentence up the top there. So that's just calling out that there's a complex algorithms document and the derivation could also be read in there. And then right at the bottom, we have a simple hyperlink out to that PDF document. The derivation is still left in the define file. It still doesn't look good. It's still almost impossible to read. The plus side to keeping it in the define now is the fact that if anyone is doing any machine readable tasks, they're trying to automate things through their define file, then the derivation is still given in the define, but then an easier to read version is in the PDF document. So looking through, so this is after we got it back from the client, they provided this nice derivation and update. When we clicked on the link, it took us out to this EX-dose derivation listed in a PDF document. very basic, just created in a Word file and converted to PDF, but at least now we can make sense of that derivation. But the key point, about this webinar really is sort of focusing on some of the details that often go overlooked. And we did gloss over this initially, but then looking at it again, just thinking about how terrible this derivation looked, we actually played around with it all, and the two derivations are completely different. So the one provided in the define file was actually for a completely different study, and the one in the PDF file was correct. So we went back to the client yet again, and they updated their define to put in the correct derivation that was lacking before. So the next issue that comes up is what I like to call scattered information. So this example is using Define 1.0, which is basically obsolete now. But the main point is that it's really not the Define 1.0 standard that's causing the issues here. It's how the tool that was used to create this define file put things in a little bit weird. So instead of comments, really they've defined derivations for everything. Every single variable had a derivation. The problem with it was the derivations are not aligned with the variables. And you have to navigate through the Define.xml and piece together all the information yourself. So a good example would be EXADJ, dose adjustment. So that's actually derivation 105. So to look at what that comment is, we have to click on 105, and it takes us down, and we can see that the derivation is simply just ex.exadj. So that derivation, or that comment, really offers no value, and if anything, it took us time to click on that and to read it and to figure out that it offers no value. So now looking at derivations 107 and 108, they say set the value using protocol info if it is not available directly from CRF. Again, the problem with this define is I can read derivations 107 and 108, but I've got no idea what variables they correspond to. So then clicking back, it looks like derivation 107 is for EX dose form, and it has an origin of assigned. And then 108 is ES dose frequency, and that is an origin of CRF. Really, the problem with the origins here are that the comment is mentioning the protocol or CRF, so really the comment is inappropriate for EX dose form, as it's got an origin of assigned, and then for dose frequency, they've put the origin as CRF but no page numbers. So it really does, having that info separated out like this with this tool, not only is some of the info incorrect, but it takes a long time to figure out that that information is incorrect. So for this particular client, the first thing we had to do, we just imported and exported in Enterprise. It takes about 10 seconds, and then it just pulls all the info out and puts it into Define 2.0, but still 2.0 or 1.0 is not the issue. The key here is that now we finally have all these comments on the right side aligned with the variable names on the left side. It's much easier to read. We're not clicking all through the define file, navigating everywhere. And really, once we got it to this level, just through importing and exporting, then we're able to go through and take our time and update all the comments correctly, delete any that were unnecessary. So another big topic is code lists. The FDA consider code lists fairly important. A year ago at the Fuse CSS, they had a poster, and in that they stated that a separate unit code list not used for each variable is a common issue that impacts review. So a very basic definition for a code list is that it should show all the intended data collection for that variable or value level metadata. So a quick example of a code list here. This is a fairly common example, and then we'll get into some of the issues that we see. But a simple CRF page is collecting 3 different values for race. When we look at the final collected data, out of those 3 CRF options, only 2 were actually checked. And then in CDISC CT, the code list has 5 possible values. So the key here is that the Define.xml shouldn't have just the 2 values in the data. It should have all the possible values from the CRF. So in this case, we'd have 3 values in our race code list. So now we move on to some of the things not to do with the code lists. So one common issue, and this is what the FDA poster was hinting at, was you should not have one unit code list in your define file for all of the unit values in your data package. So if you had 1 unit for EX dose and 30 units for labs, you'd actually have 2 code lists in your define file. One code list with just 1 value for your dose units, and then a separate code list for your standardized units in labs, which would have the 30 values relevant to labs. So some of the automated tools can add to the confusion when creating your code lists. Some of them do force you to create that 1 unit code list for everything. Another issue we see with some of the automated tools is code lists destined for other data packages in your define file. So what we mean by that is quite often we'll be looking at some SDTM data and see a whole bunch of code lists that are not relevant to SDTM at all. And it turns out that they combine all code lists for SDTM and Atom and put all of those code lists into whatever define they're working on. And then the last big one with code lists is you should not create code lists with all the values from CDISC CT. So surprisingly, this happens a lot too. Currently, I think there's a little bit over 600 values in the unit code list within CDISC CT. And surprisingly, quite often we do see many finalized data packages, and there'll be, again, just like with exposure, there'll be 1 unit in exposure. You click on that code list, and all of a sudden, the code list presented to you has over 600 values, and it's really not relevant at all. You could argue that you'd probably be better off not providing a code list at all, rather than providing every single value out of CDISC's code list. So we've sort of piecemealed this together, but a quick example of what we mean by the 1 unit code list. So as you can see here, the first five values here all have a hyperlink called unit. So what we're saying is that EGOResU subscribes to the unit code list. And then when you click on that code list, you'll see all of the relevant values from that code list, from that CDISC CT code list that are relevant to this study. And then the last 2 entries are our units for PC, and there we can see that they're taking it from a different unit code list. And then if we were to click on those individual code lists, you can see that for EG, we have everything was collected in milliseconds. For our exposure units, we have an EX dose U code list. It subscribes to the CDISC unit code list, and it has 1 value of milligrams. And then we have separate code lists for our original units in labs and our standardized units in labs, because we actually do have some differences there. And then again, separate unit code lists for original and standardized results in our pharmacokinetic concentrations domain. And then for PP, it was actually the same original and standardized units used throughout the PP domain. So there we just combine them into, rather than making a separate code list for PP ORES U and PP stress U, since all the values were common between the variables, we just stuck with one code list there. So here's a quick look at a very simple screenshot of what we've got in Enterprise. And it just shows how a lot of what we've been talking about in this presentation has been mainly focused on content. With all of the automated tools, all of our Define code, we haven't really talked about that. The really nice thing about Enterprise is you really don't have to think about any of the code. Everything's automatically created from value level metadata. You can have code lists automatically created. Import the annotated CRF, which is an excellent feature. It'll actually scan your entire CRF book. And then for all the variables it finds annotated, put the origin as CRF, put down the relevant page numbers. So that takes away hours and hours worth of manual work there, and also takes away a lot of QC work. And then at the very top right, it might be a bit hard to see, but there's also a real-time validation. So each time you hit save, you'll actually see that issue count come down. So there's no need to be endlessly running validation tools. You just hit save and the results are automatically given to you. So further reading. The first link here is to the Define.xml standard on the CDISC website. They will have, so currently if you click on that link, it'll take you to standards for version 1.0 and 2.0. And version 2.1 should be released by CDISC in the near future. It's been out for public review for over a year now, so hopefully 2.1 will be released soon. The second link that we have listed here is to the FUSE working group. And this particular group is working on the completion guidelines for our Define.xml version 2.0. That group, I believe that is very close to publication. And then lastly, previously we mentioned about a FDA poster at the 2017 FUSE CSS. The 2018 FUSE CSS recently took place, and we have a link there to the FDA's poster. That is very relevant for anyone dialed in today, because it is purely focused on issues in the Define that C2C in their Jumpstart reviews. So just a quick summary, the Define.xml really is for everyone. You should not need a medical degree to review it. You shouldn't know SAS code in and out in order to be able to understand all the derivations. You really want to keep it simple, and especially with the derivations, make sure they're correct. And I think one good bit of advice is, even if you're just reviewing a Define, you're not creating it, you're not QCing it. If there's something in there that you can't understand, you should really work with the owner of the Define file just to iron that out. And just to simplify it and get some good text in there that everyone can understand. Okay, and we'll start to look at questions now. Thank you. So the first question is, if a variable has more than one origin, for this example, CRF and derived, what should go into the origin column? So this is a new feature with Define 2.0. So previously with 1.0, the origin, there will be multiple origins listed at the variable level. So unfortunately, I don't think I have a good example in my slides, but if we look here, so we're now at the variable level. This was really sort of all that was available to us with 1.0. So if we look at AE SPID here, and it's got an origin of derived, if it was derived and from the CRF, in 1.0 you would have CRF, comma, derived. Now in 2.0, which hopefully everyone is using, at the variable level, you would actually have the origin left null. And then at the value level is where you would put in your different where clauses. So then you could state for each different scenario when that SPID value came from, when was it derived versus when was it collected on the CRF. So one of the questions was, can we create a separate document for our algorithms, or can it be part of the SDRG? So that is a very good question. There's no set standard around, in this presentation, we just called it a complex algorithms document. There's no set standard around what you call that document. The main thing is that it's linked to from within your define file. So when someone receives your data package, it should, all in the one folder, you should have your XPT files, define file, reviewer's guide, if applicable, the annotated CRF. And then if you need to format your algorithms, such as here, you can really call that document whatever you like. It really should be a PDF document. The FDA, I don't think they accept Word documents or anything like that. You could check the data standards catalog for that. But there's really no rules as to what you want to call it. It would be, as the question mentioned, you should definitely mention in your reviewer's guide also that there is a complex algorithms document. And we certainly don't need every derivation to be in this document. It's really just the hard ones. For a lot of studies, you possibly won't even need to create a separate document for your algorithms. But then for some, you might have to actually, just for a handful, create that document. Sorry, just reading through the questions here. So one of them here is, the question is, do you usually use the freak code list for CM dose frequency? This is often a messy field. We code them as much as possible. Is that a good way to do it? So unfortunately, I think the answer is yes. Often, especially with conmeds, the frequency is collected in free text. In that case, for whoever's converting that to SDTM, it's, really down to bad data collection, which, leading to that free text. So you do have to do as best you can. And yeah, that would be trying to convert as many many values to C to CT as possible. But unfortunately, in reality, you're probably not going to get all of them done. So I would just do as best you can. And then you definitely will end up with values that are not in C to CT that really are free text, but you're going to add them to your code list in your define file and show them as extended values for that frequency code list. So the next question is, if there's a long derivation and it's linked to a complex algorithm document, should we limit our wording of the derivation in the define file? That is a good question. There's no real hard and fast rule for this. So it's certainly not a requirement to have the actual code in there. There are some, there is a method to provide the exact code in Define.xml. But really, I'd personally, I would include the entire derivation in the define file. And as we saw on that example, it is very messy. It doesn't look nice. But again, I guess the only reason for leaving this in here is just so that if anyone is purely looking at that define file, and I think this would be, only someone doing an automated process reading in the XML code, which would make it too messy for them to get that derivation out of the PDF. As messy as it may seem, at least the derivation is still provided in the define file here. So yeah, I wouldn't limit the amount of text you put in the define just due to the lack of formatting. It's probably best to include it all if it's relevant. So the next question is, when we leave origin to null for multi-origin variables in the variable tab, do you suggest to leave a comment to guide reviewers to the value level metadata section to see the origins? It certainly wouldn't hurt to include a comment there. Thankfully, the define file, when it sees the value level metadata, it will actually create a link there for you. So you'll see that there's no origin defined at the variable level. And then that variable will actually have a hyperlink. And when you click on that, it will take you down to the value level metadata section. So it's a bit of a gray area if you want to put a comment for all of your variables that have multiple origins. Certainly would be a good idea if it's a little bit confusing, depending on the data collection. Okay, so the next question is a little bit complicated. For dual origin fields, what is the recommended extent of value level needed? Is it just ORES, or do we need to generate value level metadata for every variable of dual nature, such as our dates, test codes, etc.? So yeah, this is a good question. So let's take labs as an example. A lot of the time we'll get, at every regularly scheduled visit, there'll be central labs collected and they'd come back as EDT. And then for your local labs, then we might have local labs collected on the CRF. So here is where you'd have a bunch of fields that would have multiple origins. So your results, your units, and your dates would all have origins of either CRF or EDT. And there's possibly your high-low units or high-low ranges. There's a whole bunch of variables that really, in this example, that would come from either CRF or EDT. So therefore, technically, you could go through the trouble of defining variable level metadata for all of those fields. So your results would definitely be a good one to say that, for this lab test in this wear condition, all of my results are integer and they are EDT. But for this other lab test, the results are float and the origin is CRF. Now, whether you want to go through and define that same, so now we've got the variable level metadata defined for ORES. Personally, I don't think it's necessary to define it again for date and for your high-low ranges and for your units and everything else. That is a bit of a judgment call, but just from my own experience reviewing some define files, when people get a bit crazy with the value level metadata, it really just makes the define file much bigger and is more time consuming to read. And finally, the last question we have, just a quick clarification. So yeah, when we are leaving the origin null at the variable level, then the origin must be defined at the value level. If you have an origin defined at the variable level and you also have origins defined at your value level, then all of the origins at the value level must match the origin given at the variable level. Thank you, everyone. That's going to conclude the webinar. I know there's a lot of questions that we didn't get to today, but we will put those out. There'll be a recording of this webinar available. The slides will also be made available, and we will send out responses to all the questions. If you want to follow us on social media, we're available on LinkedIn, Twitter, and Facebook, and our blog at pinnacle21.com. Thank you, everyone, for your time.